All right, let's get the show on the road so we can try to finish. Caden, let's see social distancing. Let's see right here. Social distancing. All right, so today's gonna just basically be examples of what we're gonna do yesterday. Calculator he already gave you. All right, so here we go. Here's where we left off. Create a Venn diagram for the following data. 33 students were surveyed in one class and asked if they ever visited Panama City Beach or Myrtle Beach. So we know our universal set is 33. I have to add up. So let's let the first one be Panama City. And 5 have visited Panama City and Myrtle Beach. Somebody impressed me and told me what that means in regards to what we learned yesterday. Oh.
Right?
I don't know, Miranda. You tell me. Yep. Very good. Intersection. Right? So, 5 go in the intersection. 12 have not visited either beach. Yeah, the compliment that's going to be on here. 15 have visited Panama City Beach. We're against. Very good. That's the thing. So 15 have visited Panama City. Has to be a 10 there because in the Panama City entire circle, that can only be 15. So if we know that, yeah, sure. I don't like how people ask for one, but yeah, that one deserves it. You okay with Snickers? It always satisfies. How many, even though they're not telling you them, but we have enough now to know, because we know what the universal set is. How many went to only Myrtle Beach? Said 6. Okay. That's 6. 10, 5, and 12. That adds up to 27. And then they're going to ask us a few questions. How many students in the class have visited Myrtle Beach? How many students in the class have visited Myrtle Beach? None of the above. What is the probability? Okay, so now we're getting into probabilities. Remember, probability is a ratio. What you're observing divided by total possibilities. Sorry, or we call them sample space. What is the probability that a randomly selected student from the class has visited Myrtle Beach? Well, 11 out. Read it that way. Bruce is in 1 out of 3. There are 3 ways that probabilities can be expressed. One is as a fraction. Let's make sure it's in the simplest form. Another will be as a decimal, which in this case we have to round. 0.33. And finally, the last one will be as a percent. 33%. So what is the probability? Okay, this one you see a P on the outside, that means probability. So we're looking for a ratio of the union of Panama City Beach. So Panama City Beach, Union Myrtle Beach. All right. So how many people went to the Panama City Union Myrtle Beach? Meaning either or. One or the other. One good. 10 plus 5 plus 6. Union means anything on the inside. 21 out of how many total? 33. That can be reduced to 11, as a decimal, that's gonna require rounding. 8%. Sorry, 0.64, yes, would be cool.
And maybe that's like. I was looking for my phone, you don't have it.
Any questions there? How are you feeling about that, Caden? You like that seat better than the one in front? Draw Venn diagram. The following data, 34 sophomores were surveyed and asked whether they are taking geometry and or chemistry. So 34 is gonna be our sample space. Say geometry. 22 are taking chemistry. Okay, but we don't know how many of those go in the intersection. 8 are taking neither geometry nor chemistry, so I have to put 8. 2 students are taking chemistry and not geometry. So if it's chemistry, not geometry, I know 2 can go there. The only ones I can put so far are, I know where that goes. Chemistry and not geometry would be in the chemistry circle, but not in the intersection. And I know that I can put 8, or they're not taking anything. Okay? But now that I know this was the key clue here. Now that I know this, I can go back and revisit this one. If 22 students in total are taking chemistry, what can I now put into the intersection? 20, yeah. And now that I know 3 out of the 4, I can now go revisit this one and see how many students are taking geometry and not chemistry. 4.
4, 7.
If you add that up, that gives you 30. There's no question.
Oh, yeah, I keep forgetting the 8. I was like, how do you say?
Oh, okay, no, here are the questions. I guess I just put them on a separate slide. Alright, so these are the questions. What is the probability, so we're looking at a fraction or a ratio, that a randomly selected sophomore from the group surveyed is taking geometry? So we're looking at geometry is 24 out of 34. 24 out of 34. That's a really 12 out of 17. You're gonna have to round up the decimal. How we doing at home over there? Any how many showing up? Okay. 71. What is the probability that a student taking chemistry is also taking geometry? All right. So now here's where we're getting into conditional probability. Because now, by saying that a student is taking chemistry, we are now limiting our sample space. Remember what we went over that vocabulary at the very end yesterday? Okay. Now we are stipulating a condition where now we're not looking at all 34 students, we're only looking within chemistry. So that means my sample space is going to be 22. And what is the probability that they are also taking geometry? So now what we're looking at is the intersection. Out of those 22, how many are in the intersection? 20. 20 out of 22 is 10 out of 11. A rounding party with our rounding friends. So it's about 91%. So 91, also known as
Highly likely.
highly likely that if you limit yourself within chemistry. Okay. Now here, this is important because you have to, this is a terminology here, this is location, so you have to understand this. What did I tell you already the P stands for? Probability. This stands for on the condition. What is the probability that somebody is taking chemistry on the condition that they're already taking geometry? That's gonna limit our sample space now to only kids that are taking geometry. Which were, how many? No, 24. 24 are in the geometry circle. And out of those 24, how many are also taking chemistry? 20. That was the intersection. That can be reduced by 4, giving you 5 out of 6. 5 divided by 6 is 83, also known as 83%. So then sometimes you'll be asked like some type of an analytical question or what is more likely to occur? Are you more likely to select a geometry student within the chemistry students or a chemistry student? Which one is more likely? About likelihood? Which one of these scenarios is more likely? Somebody who is already taking chemistry also happens to be taking numbers. Hey Ferris, you're awfully quiet. Alright, you're there? Al caballo, what? I know, right? Yeah, that's good, man. That's taking eggs.
Sports?
That one's taking eggs.
Horse Eddie.
So the step caballo is caballo is equal.
Oh.
So alright, so here's a two-way table which works as you saw on the example from yesterday with the foreign language and the sports. This goes hand in hand with the Venn diagram. And it works a lot on conditional probability, also known as dependent events. Or one, the chances of one event happening depend on whether or not something else happens. Okay, what is the probability that a randomly selected student is a freshman or likes the food? What is that word or imply? That we're looking at the union, right? So, okay, this is comparing, let's see, we have freshmen, sophomores, juniors, and seniors. Like food, did not like food. But if I say or, meaning I want the union, I'm looking at the total. Okay? I have to go back to this. So when you have or probability, this is still from yesterday, I haven't touched it. Okay? Really the only one that you have to remember tells you when you're looking at or probability, it's the probability of one event plus the probability of the other, but minus what does the word and mean? What is the intersection? Minus the intersection. Why? Okay, well because you can't double dip. Meaning, let's say that, let's go back to this problem here. And by the way, the only real difference here between these two OR formulas is that this one doesn't have an intersection, but that's fine, because if you only remember this one, and there is no intersection, then you just minus 0, it doesn't count. But probability of one plus probability of the other, but minus the intersection. That is the most important for OR probability. So let's go back to the example, right? See, when I count all the total freshmen, I'm already counting the freshmen that like food. It's not like they're gonna clone themselves, because then the next thing I'm gonna do is I'm gonna get all the people that like food. But these freshmen that like food are being counted twice. They haven't cloned themselves, so in order to account for that double dipping, I have to subtract those 85 at the end. Okay? So the probability of one event, so let's say it was a freshman came first. How many total freshmen are there? 129 out of how many in total? 564. Plus the second event. How many people like food? Like food? How many total people like food? Or probability plus 294 over 564 minus the ones that you're double dipping minus the intersection. So we're also going to say over 564 and get off on the denominator. 129 plus 294 minus 85. 338 over 564. Those are both even, so we know that it can be reduced. How much will be reduced by? I want to reduce first. You can reduce it by 2. 169 out of 282 equals now the decimal. Decimal, so that's about 60%. 60. And just also a very common occurrence that usually when you're expressing as a decimal, usually actually 4 decimal places is very common. So extend all the way to 4 decimals. I'm leaving it at 2 now, but yeah, we'll start doing it from now on at 4. Just 4 decimals is usually very common. What is the probability that a randomly selected student is a freshman or a sophomore? Okay, so let's go back to this. So when you're looking at OR probability, you saw the word OR there, right? You saw the word OR? Mm-hmm. The difference between OR is whether the events are mutually exclusive or not mutually exclusive. Okay? The first example was not mutually exclusive. The word exclusive is like independent of each other. So is it possible that someone can be a freshman and like food at the same time? Yes, there was an intersection between those two. But the one that we're doing now, can a person be a freshman and a sophomore at the same time? There's no intersection. That's why that's the only difference in the formula is that in the one where they are mutually exclusive, you don't see an intersection of those. But that's not a big deal because there's no intersection. So all you would be doing if you just memorize this formula down here at the bottom is that since there's no intersection, you're just doing -0 at the end. There's no intersection. There's no intersection of freshmen and sophomores. So all we're doing here is just adding the 2. What's the probability? It's still OR, okay? And actually here, another thing I want to go back and add to this. So we already did word association, intersection, associated with and, union applies to OR. Here's another thing you want to remember. And goes hand in hand with multiplication. When you're calculating and probability, usually there's going to be multiplication involved. When you're calculating OR probability, you saw on the one that we just did with OR, we added. We had to subtract at the end, but we added. And look, you can see here with the end, multiply. That was also, dividing. We'll get to those. What is the probability that a randomly selected student, so freshman or a sophomore? Okay, so what's the probability of a freshman? 129. Remember, these are called the margins. The marginal frequency. 129 out of 564. What's the probability? So we're adding because it's over probability. What's the probability of being a sophomore? 142 out of 564. And then if there was an intersection, then we would subtract it, but there is no intersection of freshmen and sophomores. You can't be both. They don't cross each other. Two-way tables would literally have intersections. On the first problem, freshmen cross with likes food, and that's where we saw the 85. Freshmen and sophomores don't intersect, so it's almost the same thing as just saying at the end, well, hey, minus 0. We'll be the ratio minus 0. 129 plus 142, Ferris, you following along? No, 271 over 554. No, that was Ferris. So we'll just divide it. Yeah, and then I told you we'll start going up 4 decimals. Very nominal decimal. So I'm getting 0.4805. 0.4805. But as a percent, you can just, you know what, let's do this. That'll be 48.05. Very close to 40. Ferris, you there? Organic, you there? All right, Jason, roll call. All right, yo. If a randomly selected student does not like food, what is the probability that he or she is junior? Okay, so now this is conditional probability. It exactly falls under the and category. Where you if the student, we have already accepted that they do not like food, we are limiting our sample space. We are only looking at the row for not liking food. How many students do not like food? 270. So we're limiting our sample space to 270. And out of these kids that don't like food, what is the probability that they're a junior? How many juniors fall in that category? So you might have to reduce as a fraction, 56 over 270.
They're slowly dying.
28 out of 135. Out of decimal. 0.2074 I'm getting. And then as a decimal, I'm sorry, as a percentage, that would either be 21% if you're going to 0%, or 20.74% if you were just. I usually, it looks kind of, you can answer a good question, I'll give you snippets. What is the probability that a randomly selected student is a freshman given, okay, this word given means that we are accepting that something has to be true already. That is gonna be the entire sample space that they like food. So what's my sample space here? This is visible on the table, right? Can you see it? On the table. No, that's really good work. Oh. 29, why are you tripping? They like food. How many kids like food?
Oh.
Hey, you know what? There's just a lot of kids that don't like food. And who doesn't like food?
Exactly.
It's crazy. It says food. It doesn't have like a service.
I think they're slowly dying inside.
294, and out of that 294, just looking at that row, how many are freshmen? 5. We got calculated to that for us. Yeah, that can't be reduced. Decimal and get it. 391. Just pay attention to the question and what it's asking as far as how many decimals. That's 2891.
That's why you need the.
I don't know. They said that they were gonna move that over here.
Called big
Hey, telling you the period phrase is called, it's like, it's called, you know how to call it. This is borrowed, yeah, those are projected, but annoying because it gets, when I do this, as she said, you get off my back. It's cool for her, but it sucks for me because I can't see the board.
Oh, yeah.
So I'd rather have it on the
Why
top.
don't you put the cart on the table?
What about those that are like, just think of them with the.
Yeah, the one that you have it right in front, but those are kind of built into the. What?
Yeah, see, that's this.
The table shows the approximate distribution of votes in Texas's 5 largest counties. Find the probability. So here we go. All these are going to be fractions. That a voter from Tarrant County voted for George Bush. If we're saying the voter has to be from Tarrant County, what is my sample space? How many people are there from Tarrant County? Oh, they haven't done the margin for you. So you're going to have to add them. Tarrant County, you're going to have to go across the animal. 559, I'm getting in my head. Huh? So what is the, find the probability that a voter from Tarrant County, we've already accepted now that they have to be in that county, now voted for Bush, that's what I'm looking to measure, that's gonna go in the numerator. Out of those, how many voted for Bush? 349. 559. Check my math on the 559, because I have it in my head. That's right. Only one more Friday.
I don't mind unless it's a game phone.
Alright, so then now, does it tell you, and it doesn't say how to write it, so.
No, I was talking about.
0.6243, which is a, 62.43% of voters voted for. What is the probability that a voter voted for John Kerry and was from Dallas County? Okay, so in this case, we're actually not accepting anything, because it just says that a voter voted. Okay, it doesn't say where they have to be from. Okay, so this is just a voter voted for both of them, and, so what are we looking for? And means intersection. How many people are in the intersection of, Perry and Dallas County? What's the number in the intersection of Perry and Dallas County?
4.
Hey, oh, yeah, what she said. It is 326. Now the annoying part is we're gonna have to add up all the numbers. What? 581 plus 135 plus 645 plus 9 plus 207 plus 3 plus 6 plus yeah, everything. Plus 3 plus 448 plus 7 plus 5. I'm getting 28. 22. Yeah, and this is, it's difficult, but it's a little bit of reading comprehension also. You have to be able to understand what it's asking. This is saying that a voter voted for both of them. What's the probability they voted for both of them? Well, that's how many voted for both of them, but they just said a voter. So, it's at 28. 22 number, assuming I use the calculator. Okay. Those are both even. You're gonna have to be able to reduce them. I love my fraction, but it's, oh, goodness.
When you ask them if it's something you can calculate it.
Remember, calculator is only.
The 336 divided by 2, 160. 28, 22 divided by 2. I know that can be more than what it is. Divided by 28, gives me 0.1191. I just wanted to change things up and show you things can be different. Because the decimal, sorry, the percentage being the nearest percent. What is that to the nearest percent? 12%. So that's 11.91%. 11.91 to the nearest percent. But man, how come before you had a decimal and now you go on? So it will be different.
On the test, are you gonna have to put it, like, the numbers?
Well, on the test, I try my best to put the directions, and for some reason it slips by, I give you the benefit of the doubt. As long as your answer is correct, if you're not specifically told how to round, I usually don't penalize the rounding.
I don't know
You don't know how to round? Okay. So what is the probability that any voter, okay, so it looks like that's gonna be the sample space, chose a candidate other than Bush or Kerry? Okay, so any voter is our sample space, that's that 28, 22. But what's the complement of Bush and Kerry? Or just add up all the others? What would be in this margin? 11 and 9 is 20. 20 out of 28, 22. Cancer says it's only be divided by 2. 10, 28, 22, divided by 2. 10 out of 11. Really tiny. That's the decimal top out. 0.00. 0.0071. So that's 0.71%, right? 0.71. What would that be to the nearest percent? We're going to the nearest percent. Huh? No, just move it over. 0.71, what is 0.71 round up? 0.71, the number 0.71 to the nearest whole number is 1.
So basically, 1 out of 100.
I mean, the rule is not absolutely valid, but yeah. What? How do what? How do I reduce? I put on a calculator. There's a fraction button that usually says like ABC on it. And when you hit equal to I also know how to reduce in my head. Greater than that button. A random survey was taken to gather information about grade level and car ownership. Yay, cars! David, my man. David loves cars over there. Estimate the probability that a randomly selected student will be a junior given that the student owns a car. So when you see given, that means that's going to be our sample space. How many students here own cars?
I don't want to talk.
In this survey, how many students own cars?
I don't know more than that.
We're only looking at owning a car, and out of that, what is the probability that they will also be a 1 out of 3, no calculator needs. Not one, Angel. This is 0.3333. Look at the nearest percent.
Isn't the first time going through?
They don't kind of go on forever, they do go on forever. Well played, man. More slides. A random survey conducted to gather information about age and employment, okay, blah, blah, blah. It looks like I have not done the margins for you, so we might have to end up doing the margins, but at least it's not as big as the last one. What is the probability that a randomly selected person has a job given that the person is less than 18 years old? Alright, so if they're less than 18, how many people are less than 18?
20.
Tripping.
Oh.
Good, 265. That's the total. And out of that column, what is the probability that they have a job?
Yeah, 20.
Yeah, I think they have a job.
I have it.
Yeah, I do have it.
70.
Oh,
I get
burn. Angel, Angel, hit the fraction button. Hit it, tell me what you're getting. Before it's too late. See if Angel's gonna tell me. He's gonna learn how to use this fraction button. Here we go, 4 over 53. Does this one, I mean, I always go by the directions, but this one doesn't tell me again how to express. So I'll just prepare you for all. Oh, here's another crazy thing. Wow, I see have a fraction in here. Got a button that says like F to D. That changes the fraction to a decimal. Hash brown facts. Boys, girls. Yeah. Also, hash brown facts. When I was a kid, I would like actually read instructions to my calculator when I was Bible.
That's alright.
There should be a button around that same fraction thing that says F and then like an arrow to D and back and forth. It just changes the number between fraction and decimal.
Why would you read the instructions?
So that I can learn all the features of my calculator. Good moment for me. I still remember when I got my first fraction calculator. Yeah, pretty much. What is it here, Miranda, what is that round to? Okay, it would be 7.55, but okay, what is 7 plus, if you were asking to the nearest percent?
Well done, you're starting.
So as a percent, if I move this, it'll be 7.55. When you're going from a decimal to a percent, it's to the right. When you're going from a percent to a decimal, it's to the left. And the way I remember it is like percentages are written to the right of the number, the percentage symbol. Decimals are usually to the left of the number. So if I have to go from percentage to decimal, I want to go left, so I have to get to the left. If I want to go from decimal to percent, and then you can get that percentage center, go to the right. It's scary, you know, every time you move it. What is the probability that a randomly selected person surveyed has a job given that the person is greater than or equal to 18 years old? Okay, so now we're looking at 18 years or older. What's the marginal frequency there?
Hold on, let me do it. I'm doing it in my head.
679, 679, 679, I think.
Yes, it is. Yeah, I do it in my head.
679, Angel's gonna use this fraction button. And what's the probability that they have a job?
587.
It's so quiet at home right now, so like peaceful. All the people at home are being extra quiet.
Probably.
So you see how Angel, when I hit equals, it gave me the same numbers? That means it can't be reduced. And then I can now hit the fraction decimal button. And it tells me that that is 0.8645. Miranda, as a percent, to the nearest percent, 86%. So once you get 18, you better get a job. Miranda, you already got one.
What can I find, a mentor?
What?
But because everybody say go to college. Screw that. I want to maybe.
A random survey was conducted about gender and hair color. What is the probability that a randomly selected person has blonde hair given that the person is male. So if we're given that the person is male, we're only looking at the male. We don't have a marginal frequency. We're gonna have to find it ourselves. 48 plus 876 plus 1506. That's how many males. We've accepted that we have a male. And how many of those are blonde? Those are both even, so Angel's excited, he gets to use the correction button, and he just discovered it's a Friday treat for him. And I'm getting 146 out of 251, but I did not need to do that because actually this is multiple choice. It looks like it's in decimal form. So I could have just put 876 divided by 1506 and 0.831. It's C.
Shouldn't it be 0.6?
Well, there's
If
only
you round it to the
one.
nearest 10.
I don't know
Round it to the nearest 10.
You want to do that?
No, I don't know how to round.
Okay, watch. Hold on. Let's just put it in the calculator. 876 divided by 1506. Okay, I'm getting, on the calculator says 0.58167337, right? But if you look at all the choices, they've rounded to the nearest, 100.
I don't know the placements either.
There's two of them. You agree that there's two of them? If you look at what it says on the calculator, I know it's 0.58, the next number is a 1. Anything that's 4 or less, is down. Anything 5 or above, you go up. You stay down. Okay. Right here, Miranda, we're looking at it with 0.58. Now let's say like this number here would have been like a 7,
It would be.
then it'd be 0.59. Whatever digit is to the left of the little box, that would either go up or stay the same. In this case, because it was a 1,
Everything else behind that is easy. That's all.
that's different. That's what you call truncating. If you're just truncating, then you're ignoring all of this. But if you're technically rounding, the only number that really matters is this next one. If that's 5 or above, then this number goes off 1. That would have been 5 or greater. If it's less than 5, meaning if it's 0, 1, 2, 3, 4, if you're truncating it, it would just stay the same no matter what. Only you asked around the box. Alright, and I had already decided I wasn't gonna go over the test anyway. This worked out fine because this is a period. We will go over. It's looking like it's gonna be like Tuesday or Wednesday thing to go over this last test a couple days ago. And then remember your assignment for week 14, which as the last time I checked, only 2 left completed. Remember you can do it on the time before that. That's due by Sunday night, and you have a performance final on Thursday. And then the following Thursday you can.
No. My parents don't celebrate Thanksgiving.
Party again? Turkey on Saturday?
That's just gonna mean more
Deep
travel.
fry the turkey, I deep fry the turkey. It's delicious. It's so good.
I don't know, my mom did it.
Oh man, deep frying is the way to go.
I am too like.
Yeah, you just gotta be careful though. If you deep fry a turkey, you gotta make sure that you thaw it completely. Because if you put in a frozen turkey into a deep fryer, it explodes.